This topic is probably the most important topic to understand in order for you to successfully pass your chemistry class. You will be converting units all semester long. So let's start with understanding the idea of unit conversion and how conversion factors work. Let's say you wanted to translate a phrase from English to French, but you don't speak French, you only speak English, and you don't have access to Google Translate. You do, however, have a friend who speaks both English and Spanish, and your friend knows someone who speaks both Spanish and French. So if we wanted to go from English to French, your friend would translate the phrase from English to Spanish, and the person your friend knows would then translate the phrase from Spanish to French. Notice how the people who knew two languages were either in the middle or at the end of this, and the person who only knew one language was at the beginning. This is how unit conversion works. The given unit is what we start with, and your conversion factors are in the middle and at the end. A conversion factor has two different units. They allow us to go from one unit to a different unit. Notice that we always align the same units across from each other so they can cancel out, and thus allow us to change the unit. You know where a conversion factor goes based off of the previous unit. You will often see the setup of unit conversion questions like this, where the point where the lines meet represent multiplication. As you progress in this class, you will see questions like this or even longer setups. Again, this just means there are multiplication symbols here. The metric system and dimensional analysis are two topics where unit conversion is used. Both topics allow us to convert units of length, mass, volume, and time. The metric system allows us to convert units that share a common base. For example, we are able to go from milliliters to liters or from kilograms to milligrams. The base units we commonly see are grams, meters, and liters. While for dimensional analysis, we are able to convert units that do not share a common base. For example, we are able to go from feet to inches or kilograms to pounds. A common mistake students make with the metric system is not knowing if they should divide by a number or multiply. This disconnect comes from not understanding how to find the conversion factor. So let's fix that. These numbers are actually representing these small and large numbers. These are written in scientific notation. We just don't show the one in front. Let's say we were asked to convert from kilograms to grams. We would start with the given number first, then make sure to align the same units across from each other so they can cancel out. Now, this is where most students get stuck. If you feel this way, then I recommend trying this trick of mine. Always place the 10 raised to an exponent with the base unit. So remember, our common base units are grams, meters, and liters. So since this is kilograms, and the metric system shows that kilo is 10 raised to the third power, this will go with the grams on top. Next, always place a 1 with the different unit or the unit with one of these prefixes. So a 1 goes with the kilograms. This trick will stop you from guessing and help you get the setup right each time. So our kilograms cancel and we are left with this as our answer. Here's another example. This time we are using multiple conversion factors. We are asked to go from kilometers to centimeters. Note that there is no way for us to only use one conversion factor because there is no conversion factor that allows us to go from kilometers to centimeters. Instead, we need to have a connecting unit, meaning we need to go from kilometers back to meters and then to centimeters. Notice that both conversion factors have to have one unit in common in order for this to work. So our connecting unit is the meters. We'll start with our kilometers next. We want to go from kilometers to meters. So using our trick, we will place a 1 with the kilometers on the bottom since we always want the same units across from each other so they can cancel. And the 10 to the third power, which is what kilo is for the metric system, will go on top with the meters. Now that the kilometers cancel, we can go from meters to centimeters. So we will place the meters on the bottom so these units can cancel. and the 10 to the negative second power goes with the meters since centi on the metric system is this, and the 1 goes on top with the centimeters. The meters cancel and we get our answer in centimeters. Notice that the trick really helps you out here because you don't have to second guess yourself. Instead of thinking, do I multiply or do I divide? Instead, look at where the base unit is and where the unit with the prefix is. Moving on to dimensional analysis. In dimensional analysis, there are set conversion factors that you will be expected to memorize and others will be provided in the question. Here are some common conversion factors you will see. Let's do an example now. We will start with our given feet, and now we have to pick a conversion factor that has feet in it. So the only one we see is this one. This is our first conversion factor. We'll place the same unit of feet across from each other so they can cancel, and the inches will go on top. Next, we'll find a conversion factor that has inches in it. Luckily, this one goes from inches to centimeters, which is what we are asked to find. This is our second conversion factor. Now align the inches across from each other so they can cancel, and the centimeters will go on top. Multiply everything together, and this is what we get. Remember to round to the correct number of sig figs. We do not look at the set conversion factors to determine the sig figs. We instead look at the numbers given in the original question. So we would round this up to 4 sig figs. The next topic that makes up the majority of your chemistry class is stoichiometry. This is another form of unit conversion, except we are converting units that relate to elements or chemical reactions, like going from grams of sodium to atoms of sodium. Conversion factors still apply here. We just have different conversion factors that you will be required to know how to figure out, and others you need to memorize. Let's start with the conversion factors you need to know how to figure out. Molar mass allows us to go from grams to moles and moles to grams. We find the molar mass by using the masses found on the periodic table. For compounds, we will add up each individual element's molar mass together to get the total molar mass of the compound. A moles-to-mole ratio allows us to go from moles of one compound to moles of a different compound. Note, this could also be moles of one element to another element, or element to a compound, and so on. We can find the moles-to-mole ratio in 2 different places. If given a balanced chemical equation, or a way to find the balanced chemical equation, then we use the coefficients in the chemical equation. If there is no coefficient in front, then assume it is 1. For example, we can say 1 mole of magnesium nitride is equal to 3 moles of magnesium hydroxide, or 6 moles of water is equal to 2 moles of NH3, and so on. If there isn't enough information and you are only given a chemical formula, then you will find the moles-to-mole ratio by using the subscripts in the chemical formula. For example, we could state that in 1 mole of C2H4, there are 2 moles of carbon, or 4 moles of hydrogen. The conversion factors to memorize are these 2. Avogadro's number allows us to go from moles to atoms, molecules, particles, and formula units. This number always goes with these units, and the 1 always goes with the moles. Note that Avogadro's number can also be rounded to this. It depends on what your teacher prefers to use. This conversion factor is for volume and is used for gases. So whenever a question states at STP and gives you liters, you know you can use this conversion factor, which allows us to go from moles to liters and vice versa. Let's figure out what conversion factors to use in this question. We are asked to find the molecules of C2H4, and we are given 45.8 grams of C2H4. So we have to think of a plan on how to go from grams to molecules. Specifically, what conversion factors will we need? If you aren't sure what to do first, notice that all these conversion factors all equal moles. So we could start with converting our unit of grams to moles. To do this, we will use the molar mass as our first conversion factor. This allows us to go from grams to moles. Next, we need to find what conversion factor equals moles and allows us to go to molecules. Avogadro's number allows us to do this, so this is our second conversion factor. Let's set this up, starting with our given unit of 45.8 grams of C2H4. Since our first conversion factor is molar mass, we need to find the molar mass of C2H4 by adding up all the individual elements' masses from the periodic table and multiply any subscripts shown. Doing this, we get this as our molar mass. The grams go on the bottom and 1 mole goes on top, since we always want to align the units so they can cancel. Now we have our moles, and we will use Avogadro's number to convert to molecules. The 1 mole goes on the bottom and molecules goes on top. Cancel out the moles, and after we multiply these two numbers and divide by the denominator, we get our answer, which should be rounded to 3 sig figs since the given number had 3 sig figs. Because this topic is the most important topic you will see in chemistry, you need to practice this in order to successfully pass this class. And you know I love making things easier for you. Simply click the link in the description to try out these practice problems, then come right back to the next video.